A lever is used to increase the downward force or load. A man exerts a downward force on the lever. The force acts upon the rock at the fulcrum, where the man's downward force becomes an upward lifting force. The farther the man is from the fulcrum, the more his downward force is increased and the more he can lift. On this seesaw, both weights exert a downward force and are equidistant from the fulcrum. The 60-pound object on the left exerts a greater force, so the left side of the seesaw moves downwards. Changing the distance between objects and the fulcrum can change the downward force each object exerts. See how we have increased the relative distance between the 30-pound object and the fulcrum. As the distance between object and fulcrum increases, the downward force exerted by the 30-pound object also increases. This may result in the seesaw being balanced, despite the fact that the object on the left is much heavier. Drastically reducing the distance between the 60-pound object and the fulcrum minimizes the object's downward force. Meanwhile, the downward force of the 30-pound object is increased as its distance from the fulcrum increases. As a result, the less massive object can actually lift the more massive object. Remember this key point. The greater the distance between an object and the fulcrum, the greater the downward force will be. Think about the following question. In this picture, would it be beneficial to move the fulcrum closer to the man? Press pause for a moment and consider your answer. Press play to check your answer. Absolutely not. Moving the fulcrum closer to the man decreases the distance between the fulcrum and the man. Decreased distance means the man's downward force will also decrease. Meanwhile, the distance from the fulcrum to the stone increases, which increases the downward force of the stone. As a result, the man must work harder and will achieve less.